All right. Hello, ngHouston. All right. We are excited to talk with Ed Pelc here today about reusable CLI libraries with lazy loaded routes. Um, we've got, before we get into introducing the panel, I just want to go over a couple of things that we have coming up on ngHouston here. So next week we're going to have an in-person session, so there won't be any broadcast. So for those of you who are here in Houston, please come over and join us at our new home at blinds.com for a series of lightning talks that we've got going on. But then the week after that, on July 25th, we're excited to have Stephen Fluen joining us to talk Angular for designers. And on August 1st, we've got Elaine Choutard on validators. So these should be great. And tonight, like I said, we're excited to have Ed here to talk with us about reusable libraries in the Angular CLI. So let's introduce our panel. So I am Keith Stewart. I'm a co-organizer here of ngHouston. And we also have with us Justin Schwarzenberger. You want to say hi, Justin?
Hey, how's it going? Good to be here.
Great. Glad to have you. And we have Lance Finney. Say hi,
Hello.
Lance.
Hi. If you watch this, you may have seen my presentation here a couple months ago, and I've been a panelist a couple times. Usually I'm a Angular consultant and Angular trainer with Oasis Digital and Angular Bootcamp, but tonight I'm just here to learn from Ed.
Great. Great. Thanks for joining us, guys. And now for our speaker, Ed, can you introduce yourself and tell us a little bit about yourself?
Yeah, so hello everyone. My name is Ed Pelc. I run a startup called FreightChick, and we got a couple different products. Our main one's FreightChick. We also have another one called Slapshot, and we're looking to build some more, but I mostly work on that with most of my time. But recently we kind of got into trying to reuse some parts of our apps, and kind of went down the library road, and I'm going to kind of talk to you about that.
That sounds great. Awesome. Well, how do you want to do this? Do you want to get into some slides first, or?
Yeah. I have a short presentation, and then I have kind of like a demo to show everyone, or just kind of like what it looks like once you implement it, and sort of like production. But share my screen.
Okay, great.
Okay, so can you guys see this? Hello?
Yeah, we can see it. Yeah, thanks.
Okay, so kind of changed the title of this talk because I felt like it kind of needed a better name, but so there's libraries that you can generate with Angular CLI. That came out a couple months ago with version 6 of the CLI. But that's all good and dandy if you're just reusing code or kind of doing like component libraries. But in this talk, we kind of want to take it a step further and take your routes for different features of your apps that are probably generic and make those reusable so that you can kind of just install them into your other apps. So this concept is kind of libraries plus routes within the libraries, which is kind of unconventional, but I like to call it feature route libraries, for lack of a better name. But so let's start. So here's kind of what the talk's going to be about, our major points. First, I'm going to tell you what a feature library is. Then I'm going to kind of go into philosophy of why you might build one, why you might invest your time in it, or versus just doing something else. And then we'll get into how you build a feature route library. We'll cover some basics with the CLI libraries in general, just because they're new. And then I'll give you a couple rules to follow to avoid bugs. A lot of the times when you're building these libraries with the CLI, it might work when you compile it, but when you actually go to use it in your app, or maybe when you compile your app into like production or AOT mode, you can run into issues and kind of get some pretty cryptic error messages. So kind of point you in the right direction on what to do and what to avoid. And then we'll kind of show you like a project layout for smaller libraries, and then also kind of show you a more expansive layout once you have different sections of feature libraries, so that you can kind of take that layout and just build upon it. And then after that, we'll just show you a demo of what this looks like in production to kind of show you what you get with it. And then we can answer any questions that the panelists or viewers might have. And yeah.
All right, sounds great.
So, so what I like to call a feature route library is a library which implements some sort of routes within your app. It's going to be installable so that you can easily reuse it within all of your apps or products. It brings higher level components with it, much like a component library, sort of like Angular material, but a step above, more business logic. And most importantly, you can configure it to customize the behavior of your library. But the core concept is that you're installing full-fledged features into your app. It's not just like a button component or a table. It's going to be like an account system or a big analytics system that's generic, where you're just plugging in configuration data for like, hey, are you going to have Google login? Are you going to have Facebook? Or like what the name of your app is, kind of things like that. But the main points are that you're going to be able to install this via NPM. You'll get pre-made lazy loaded routes with it. I'll show you how you can reuse your Sass styles, either at a component level or globally, if you kind of want to have like a little bit of a style library that's maybe reusable for some things, where say a component in your library is going to maybe use a mixin or something, but you might also want to use that mixin inside some of your app code. Obviously, you don't want to just copy paste that, so I'll show you how to reuse that with the CLI libraries. And then also in our demo, we can show you kind of what it looks like when you're configuring these via different providers or services. So what goes into one of these? So before you build a feature route library, you need to ask yourself what should be in it. In my experience, they tend to work best with the generic parts of your application, which are either pretty static or heavily like data or configuration based. There's not so much specific to your app. It's more based on some configuration data that can be set up and passed in. The best features to reuse and turn into libraries are ones which every one of your projects will need. A few examples of these in our case are everything that you need to make a product that isn't a core business issue. So in our case, FreightChick is a shipping app. It helps you get and check prices for shipping different items. The core functionality of that is to go out and check those prices and actually prepare like your shipping paperwork. But just to sell that as a product, you kind of need a lot of other just generic systems to go with it. So you can see here, to make product and really flesh it out for larger clients, you're going to need or want most of these features. You need accounts to kind of section off your customer data. You might add in a search system once there's enough records where it's kind of a burden to flip through like a table view or a bunch of pages. Most apps that have multiple users or tenants are probably going to want some sort of team or group system, likely with permissions, like invites and things like that. You're definitely going to want a billing system so that you can collect some money once you have enough people and data using there. And then you're probably going to also want some other things like reports and analytics to kind of show what people are doing in your app, so you can send it off to a manager, a fancy graph and whatnot. But and then there's also things that are just pretty generic, like notifications. You'll see on the Google page, they have a little notification system. Most apps can benefit from that, or they would want that. You might add in a little news system to send out updates. You're probably going to need some sort of administration interface where you can reset users' passwords or have something for your support people to use, things like that. But why would you build a feature route library? They don't really seem to work that well outside of a company so far. They slow down your compilation with the current CLI setup. It's a lot faster just to stick your code within a single project if you aren't reusing it. Just based on how the compiler works, it's doing a full build for every library that you have, which can be kind of slow. But they generally complicate things. But the short answer for why you would invest in this is that time, money, and power. If you are set up for it, you can reduce the time that it takes you to build new products. You can save money because you can reuse features off the shelf now, and you get power over your competitors because you can get to market earlier, and you can just focus on the core business aspect of your app, like shipping, instead of building all those generic features, which, you can also open up a lot of options for you when you don't need to worry about basic generic features of a product. You can start to take smaller scripts and utilities or other internal programs that you might have that might not have warranted your time as investment to test it out as a product, or maybe build these features into them. And you can start turning them into real products quickly and experiment with them because the boring generic features are ready to go. They're just an install away. It's very similar to how in past years, services like Stripe and Auth0 speed up the implementation and reduce costs. The feature route libraries, you can gain even more benefits by having standard features, sections of your app finished and ready to go. I kind of like to say that feature route libraries are greater, or, they kind of give you a leg up over the component libraries. Component libraries started getting popular because of frameworks like Bootstrap, which gave you a set of standard components to compose your app with. This saved a ton of time and raised the bar of quality for apps on the internet. Feature route libraries take this step even further by packaging up common features and sections of apps, reusable libraries, which all apps that your company makes can start with instead of reinventing the wheel every time. So how do you build one of these? So now that we know all the reasons for why you might do it and what the benefits are, the downsides, let's get into how you build them. We are going to walk through building a billing library. We don't have one right now for my company, and we need to start collecting some money from potential customers. So we're kind of gonna mock up a billing library that'll have some like invoice, potentially like invoice list, and sign up with the credit card, things like that. So the first things first, you want to use the CLI. I'm not joking, it's pretty powerful. Without it, these libraries really wouldn't be a thing, at least not with a lot more effort. They definitely wouldn't be as easy. The Angular CLI, starting in version 6, like I was saying, added a new option for generating libraries right out the bat. This command, ngglib, and then you put @ and a scope name, which is usually your company or your NPM account name, and then / whatever your library name is. In this case, we're going to call ours GreatCloak because that's our company, and /billing because we're building out a billing system. So what's the CLI do when you run this command? If you look inside of your regular Angular project after you run this command, we'll take a look at what's changed. It's generated our actual library files under the new project's GreatCloak billing directory, which you see the GreatCloak corresponds to the @GreatCloak or the scope, and billing is your actual library name. It becomes basically a directory tree under projects. It's also updated your Angular.json by adding configuration options for how to build the library and other info that the CLI needs to know about it. You can customize these just like you would customize the build options for your main project. It also very importantly updated our tsconfig.json, which is important because when you first get started with these, there's some options in there that you might think to edit to kind of work around things, but kind of explain what they do and what you may or may not want to change. So the CLI has updated that very important tsconfig.json file. It's added mappings in our paths config to map our library name to its subpackages and also to the dist folder. So since the library is within our project as source files and not installed via npm, what these mappings are saying is that basically it's going to say when you import @greatcloak/billing or /billing/something else, if there's a subpackage, instead of looking inside your node modules folder for that, as if you installed it via npm, it's going to look inside your dist folder instead, because when you build the library, it's going to spit it out into your dist folder. So this is just telling TypeScript where to look for your library files. Now, this is only a concern when you're using your library within like your main Angular CLI project for your app. Usually you can either put your library code inside like your main project or product, or you could set up a separate Git repo with a separate Angular project. Just kind of ignore the main project or delete it. But if you're just importing this library from another product or a different project, then you would just install npm install @greatcloak/billing, and you don't need to worry about the tsconfig in a separate project. This is just special because you're trying to use it locally. But you don't want to mess with these. You can get into nasty things, which I'll explain later. If you try like remapping these to the source files for your library, you don't want to do that because when you basically you wind up with partial build issues and you get some really weird cryptic error messages. But the CLI on the latest version, 607, the latest stable, it does this all perfectly. So you just want to leave these options here how they are. Now, if you take a look at your library code, you can see a source directly with the standard Angular looking code inside of it. There's two parts here. There's a source/public API.ts file. Basically, everything you want to expose to the outside world from your library, whenever you import your library, you're going to want to export from this public API file. Yeah. So here's one of the first rules for things you want to avoid. You must import, or you must use relative imports for all of your files. You can't use absolute imports with libraries. You cannot mess with your tsconfig, like I was saying, to try to remap those paths to your local source files. You might get it working locally when you build your library and you'll think you're A-okay, but basically if you clear out your dist folder and you do a fresh build, you can run into issues because of a dependency resolution. And you'll also more likely run into issues when you actually go to use that library within an app. Specifically when you go into AOT mode, you can run into a whole bunch of issues. And these issues that I talk about, you're going to get these error messages that say things that have absolutely nothing to do with the actual reason for it. So basically, if you're having issues and you're not following these rules, refer back to the rules and see if you still have those. But you must also make sure that you import your barrel or index files, as they're called, explicitly. Will appear to work when you're compiling your library, but as I said, when you actually go to use it in your project or install via npm, you're going to wind up with those cryptic error messages. So what I mean by this is, say you have a lib/components folder, a whole bunch of components in there, and you add an index file so that you can export like /my_login_component/component or my_login_component.ts. And you think you can just import from lib/components. You don't want to do that. You want to import explicitly from lib/components/index. So basically, you can't use the barrel files within libraries. You're going to wind up with errors. I believe the error message that you get for this one is that it can't find the files, but you kind of get it later on when you go to use the library within your app code. So just make sure that all of your imports are using explicit. Make sure they're explicit and make sure they're relative. No absolute and no magic barrel files. So now that we have a library, you can import anything that you expose in your public API. The main thing that you want to remember here is that you're importing it from the main library name and not any subdirectories yet. The CLI uses a tool called ngPackager under the hood, and basically it builds a single output file since it compiled it so that basically it uses ngPackager under the hood. It'll take all of your components and services and bundle them up into a single kind of like production compiled file for you. You're not going to be importing from all the directories because really greatcloak/billing is referring to a single JavaScript file. You can do @greatcloak/billing/ some other name. Those are called subpackages, which we'll get into later once we start building bigger libraries. But for now, with a single package, you're just going to be importing from /billing. So lazy loading arrays. So now you can define some components and services and set up a routing module for your library. You can export that routing module and pass it into load children as a direct reference. But then all that code is bundled up in your main app. And these features are any big or they're not used on any pages, you're missing out on serious performance gains. What we really want to do is lazy load our future routes. You might try popping in your library name and the name of your module, but you'll quickly notice that this and many other combinations that you would intuitively think of might work, they don't work. The Webpack plugin in the CLI that handles processing the load children as a string, it doesn't support loading files outside of your main app source directory. So as a general rule, most of the current Angular toolchain doesn't really support loading outside of your source directory. The whole libraries and having to install them is kind of a new concept. So, or at least the tooling for it is new, which is going to make it popular, and hopefully they'll add support for these things. But in essence, you can't use a string to load from like node modules for. So how do you work around this? The solution for lazy loading your modules is to create a wrapper module, which you'll then reference with a string, but that will then reference your real library by a regular TypeScript import. This allows the compiler to lazy load your fake wrapper module and give you all the benefits of lazy loading, with the only downside being a small external wrapper module that basically just imports your real module that you want to lazy load. You can see here in our main app routes, we are using a load children string to reference the local wrapper module. And within our wrapper module, we are just importing the real module via a regular TypeScript import. Like I said, it's basically a cheat to get around compiler support for now. But hopefully eventually you would be able to do something like load children, greatcloak/billings, hashtag my module name. But for now, just what I like to do is set up an external file in my project and just make these little module files that are wrappers. One thing you want to remember here to make sure that your actual library code gets split out into a separate bundle file at the end, which is kind of like a persistent issue with these libraries you need to watch for. But one thing you want to do is you make sure that you're not importing your library modules anywhere else, or basically using them anywhere else besides for this external wrapper module. Basically, you can't have any other references. The reason you can reference it inside this wrapper module is because it's being lazy loaded via the load children string. It's not directly referenced anywhere like your app module. So now you got yourself a fancy library with the routes defined in it that you're successfully lazy loading throughout all of your projects with only a small wrapper module as a workaround. However, you've created a billing service which you now want to use outside of your library within your app code to check what package your current account bought so that you can lock out features for your users. You already have the service defined and being used within your feature route library, your billing interfaces, and invoice list. So you simply export it from the library's public API.ts file, start importing it within other parts of your apps. Everything continues to work. You lock out your shiny upgraded features depending on what level Sally is paying for, and you think you're done. That is, until you take a peek at your CLI output, and you notice your billing invoices module is now only 2 kilobytes. And upon further investigation into the code, you realize that the CLI is outputting code that now does nothing more than just import your billing services, components, and invoice routes from within your main app bundle. Essentially, you're downloading the billing code synchronously inside your main app bundle JS file with all the rest of your app code. And you're using this lazy loaded route to load this billing wrapper module, which is then just referencing code that was already loaded back inside your app module because it got bundled in there because you're referencing your billing service. This is a very hard bug to spot, and it also completely ruins the whole point of lazy loading, so we need to fix it. The reason behind this is that ngPackager generates a single output file for the whole library. The Angular compiler can't break this code up because it's no longer source files like your regular app code. And so now your main app code is referencing the service and everything else, and it's being stuck over inside your main app code bundle and essentially not being lazy loaded. Or even worse than not being lazy loaded, it's being referenced via a lazy loaded route, so it's even slower than if you just imported this directly. Solution for this is to generate multiple files for your library. In practice, this means you get to use a cool ngPackager feature called subpackages or sub-entry points. It's got a couple different names. It's also called submodules. They've kind of standardized on the subpackages terminology, so when you're doing your Googling, make sure you use that. They have a nice wiki page on subpackages. You look up the ngPackager repo, kind of tell you a little bit more about it, but we're going to tell you what you need to know on that, so you can skip that. Okay, so the idea here is to put all of your shared and exposed services into a shared subpackage, and then put your routes and route-specific components into a separate subpackage. The caveat here is that since your route subpackage is likely to depend on and use code from your shared subpackage, you cannot use the main package anymore. Essentially, you have to move all of your code from @greatcloak/billing to @greatcloak/billing/shared, and then move anything that's route specific into other subpackages like greatcloak/billing/invoices. And you can have multiple subpackages if you have, say, like a credit card sign up or like a credit card managing entry of routes or something. You could do billing/cards or something like that. But yeah. The reason you have to do this is because ngPackager can't automatically figure out the dependency graph of your subpackages when the main package is used and being referenced via a subpackage. This only happens upon fresh builds, so it's kind of hard to spot. Basically, you're going to run into it when you do a CI build, you delete your dist folder, or someone new on your team pulls your branch. Seems to be a bug with the automatic subpackage dependency graph resolution. Basically, when you tell the CLI to build greatcloak/billing, it's going to look in there, it's going to find a bunch of subpackages, it's going to try to figure out automatically which ones depend on each other so that you don't have to specify it. And if you use your main one or source directory and it's imported via any of your other subpackages, or if it imports any of them, it's not going to be able to figure out the order. Yeah. So basically the workaround is to ditch the main one for now and just make like a fake shared one. then stick everything else in other ones. And what you do here is you can see inside your source one, you just need to add an empty variable. You can see here we do export const empty equals undefined, and just add a comment that you should look in /shared instead. I just want to point out here, this is kind of the layout for larger libraries where you're going to be using services inside your app from the library. If you just have a little self-contained thing, there's no reason to go with sub-packages. It's a little more overhead. You're essentially building more libraries, so the compilation can take longer. But if it's all self-contained and you don't need to provide an API to the outside world, and you just have a couple routes or something, then you can just stick with the one package. But if it's bigger than that, you're going to have to split things off, ditch your main package, and start using a shared kind of other sub-package layout. So you can see here to set up a sub-package, all you have to do is inside a directory under your library name, so under billing, you add a new directory like shared or invoices. You add a package.json file, which has an object with the ng package attribute on it. That's just an empty object. If you go look up the docs in ng packager sub-packages, there's a couple options for that. In our experience, we haven't needed them. Built several libraries already. But they have some options for styles and things like that, and kind of remapping imports. After that, you will add a source directory and a public API.ts file inside of that. That's the standard entry point if you don't have any config like you see here. Otherwise, you can override that ng package config and specify a different, basically index or main JavaScript or TypeScript file to start with as your public API. But it's nice just to use the default config and make a source /public API file. So now that we have that covered, we're going to show you how to load Sass or style files from your libs. So you can reuse the Sass or SCSS files by distributing them via npm2, just like the rest of your library code. What you do is you copy your styles directory from any of your libs into the dist folder for that lib after you've built the lib, but before you publish it to npm. Usually you'll set up a script for this. You can see here it's just a copy -r for recursive, so it takes all your subfolders from your source projects directory into your dist folder. The caveat here is if you have your libraries inside of like a main app project. For instance, we have all these Great Cloak libraries set up inside of our Freight Chick project. When you go to import those, the import statements for your Sass files are different. If it's in that main project, then you need to use this first import, which is tilde or the squiggly dist / Great Cloak billing shared blah blah blah. If you install your library via npm, i.e. in another project, for us this would be Slapshot, then you're just going to import it as if it was npm name. So in this case, you would use @greatcloak /billing /shared and all of your file trees. So basically, if it's in your same project, you do the dist / your folder tree. And if it's in via like an npm install, that's how you got your library, then you're going to do app / whatever your library name is. The only downside with these libraries or with these styles that I've seen so far is that say you have like a login component, say you have like or let's keep with the billing. Say you have a billing library and you have your invoices page and it has some styles for like showing an invoice via HTML or something. Say you want to reuse those same styles on some other page within your app. So you set those styles up like this. It's going to import them inside your invoices sub-package, and then you're also going to import them somewhere in your app. So those styles will be duplicated once within your invoices package and once within your main app. However, styles are pretty small. Hopefully you don't have too many in there. But yeah, the benefits of this is basically you're avoiding copy pasting these styles, which is what you would be doing anyways. This just allows you to distribute them and update them automatically with your libraries. So once you have lots of projects using these libraries, you're definitely going to want to do this. And even if you just have one or two, you're probably going to want to be distributing your files this way anyways. So now let's review what we just made. Now have your first feature route library, as I like to call it. Your billing section is completely reusable. You have reusable invoice routes, which are now lazy loaded and properly lazy loaded. It can be installed via npm via a simple npm install command inside any of your new or existing projects. You just have to build a reusable backend to go with it. And if this interface doesn't require backend, then it's even simpler and better. Now all of your projects have standard and high quality features ready to go. You're just going to be pulling this billing section right off the shelf for all your projects. You also avoided a whole bunch of errors, which you might normally hit when attempting to build these. You follow those rules and some of the points that I covered, save yourself a whole lot of headaches. You also get the proper lazy loading bundle splitting, which is very hard to spot, especially if this is new. But yeah. So now we have time for Q&A. Or actually, I think my slides got a little bit mixed up here. There we go. So now we have a little demo of kind of what this looks like in production. And I'll show you a little bit of what the code looks like for a built library that we've already made and are using at my company. Yeah, so let me, oops, okay. Let me just switch this screen share so it shows my whole screen. Okay, so as you can see here, slapshot.com. This is just an app. It processes wood slabs like these. You can see two guys. These are some of the slabs they process every day. It's an app we built for one of our parent companies. We might sell to other people, yada, yada. But you can see it kind of got a little bit bigger. We wanted to add our account system, and we wanted to reuse it for freight trip. So now you can see we have this login button. We have this whole login page. If we go look at the network here, and we just go back, or pop up the JS, you can see it loaded our main JS files, a dashboard, and some other, I believe, vendor files. But here, let's log out. If we pull up the login page, you can see it'll load login specific routes. I disabled the cache. That would explain things. Yeah, don't disable your cache when you're in the middle of nowhere. But anyways, you pull up the login page. It's lazy loading this entire login route. It's also lazy loading the sign up, password recover pages, the OAuth callback pages for once you log in with Google or something. And you can see here that on our actual Freight Check app, it's using the same code. This route is defined inside a library. We just installed the GritCloak accounts library, and it's using our internal account system. We could have 10 different products now, and we need the front end for accounts. It's just installable, just like our backend file library account is installable. You know, we don't have to go take some account component library and set up all the routes for it, set up all the resolvers and dependencies and other things like that. You know, we're just installing, we're saying, hey, load this account module. So now we'll kind of jump into what it looks like from an app perspective. So this is Slapshot's package.json, and we can see here we just install our account library. You can see here it's marked as a dependency. To use it, it's really only a couple lines. So you can see here, we'll go to our routes. But so you can see we have our account routes. How this works is we are cheating a little bit and we're defining the paths for our routes inside of the library. Since you can't do the full top level route definitions inside your library because you want to be able to lazy load them and you need to do a load children somewhere, we're basically working around that by setting up our paths for the top level routes as an enum which we export. When you do that, you want to make sure that you're exporting from your shared library so that you're not, so that you're not importing your lazy loaded subpackages. Otherwise, it would break your whole lazy loading setup. But you can see here, it's loading our wrapper module, which if we go up to external, you can see it's just importing the login module and just defining a simple wrapper module here. Another thing I want to point out is that to configure these libraries and customize them, that's a thing. Angular has a very nice provider system built in with dependency injection. What you want to do to make your libraries easily configurable is either set up a service where you're going to configure some variables, or what's even nicer is you set up a provider. In this case, we have a list of OAuth providers, which is basically like single sign-up. And we're saying that this app lets you sign in, log in, and sign up with Google. We also have some other ones like Facebook. You could add LinkedIn, Twitter, whatever. But the point being is that to get accounts set up in an app at our company, we're going to install a library, configure one provider key to say which OAuth services we want, and we're good to go. It's easy as that. But the account system is kind of like a proof of concept for these feature route libraries. You can see some of the downsides if you have lots of top-level routes. Where we envision this being used more so is with our reporting system, which is kind of like /reports, and then you'll pull up a specific report. It has a bunch of widgets and many different subpages on there, where in that case, it would just be a single path, reports, and load the single submodule, and you'd be off to the races with that. But this is kind of what it looks like from here. We'll show you the other side of it inside the FreightCheck project where the library is actually set up. You can see inside our projects directory, we have an account. We have a whole bunch of subpackages, which just define some components. And you can see inside of our actual login subpackage, we're defining a router for a child. This is the actual module that's lazy loaded, and it's going to be loaded via children or via the wrapper module, which is loaded via load children. So you're always going to do an empty path as the top level for these because your parent app controls that top level route for you. But you can see here we can do cool things like we can define the title for this route within the library, which reduces your work when you actually go to use this thing. You're not worried about doing things like you might do with just a component library, like setting up titles and resolves, things like that. You can configure them all within inside your library, which is really nice. The other part to doing that route pass, so we'll show you that route pass hook. So when you import, these are the top level names of routes that we have kind of as standard. The reason you want to put these inside your shared library is so that they can be defined within your library and controlled via that. You don't want to have to go update 10 routes when you decide that you want to use sign in instead of login as your route name. You know, you just want to update it in your library, and you just want to say npm update or ng update inside of all those apps. You know, you want it to be controlled by the library. Everything that's specific to the library should be in the library code so that you can just update your library, and all of your users just have to download the latest version of your library. Now, you shouldn't have to go update every one of your products. It's a thing of the past now. So feature route libraries, get rid of that. But yeah, so that's kind of it for the demo and talk. Hopefully maybe we have some questions from our panelists now, or if any of the viewers have questions, I can kind of dive into any more specifics or things like that.
Well, there is one question from a viewer. What if we aren't using version 6? How much of this is exclusive to later versions of Angular?
How much of this requires Angular 6, they're saying?
Yeah, pretty much.
So I'm not sure if it requires Angular 6. What I am sure is that it requires the Angular CLI version 6, which I believe is compatible with older versions. The reason you want the CLI version 6 is that that's the version they added library support in. If you don't have the CLI version 6, you can still do this if you go use the underlying ng packager tool. It's just your life is going to be a whole lot harder. You're going to waste a whole bunch more time. I'd advise just getting your projects updated to CLI version 6 so that you can let the CLI do it for you in the standard way.
So do you see any advantages to doing it this way, where you have multiple separate repos involved, as opposed to putting everything together in a single repo and doing more of a mono repo approach to this?
So right now, like you could see in our code, we have about 7 libraries defined in our main FreightShake repo. The reason for that is we've been working on upgrading FreightShake, finishing an upgrade. The last part's been an upgrade for FreightShake from AngularJS to Angular 2 Plus. And we were kind of taking parts of the app and turning them into libraries so we could reuse them in Slapshot and other products as we kind of did that. So it's just kind of there to simplify things right now. We'll probably eventually move it out into either a separate Angular libraries project or maybe even individual projects if we need to split it up even more. It's not like we have dozens of teams working on this right now, though. So if you have different people or different workflows, then yeah, you could totally do a library per Git repo, or you could have a single Git repo with all your libraries, or you could have multiple Git repos with a couple libraries in each one. Basically, what you're doing is you're making a CLI project for whatever Git repo you make, and you're going to stick one or more libraries in there. We just happen to stick it in our main one. There's benefits and downsides with both ways. Right now, it's just simpler for us to keep it in the main project. We don't really have a reason not to. I suppose the only reason that you wouldn't want to do that is that if you're using a lot of styles, which we will get into later, once we start making more and more features use this library setup, there is an issue because the styles don't have kind of like a concept like tsconfig's pass options to basically map to names or import names to different folders, or at least not that I'm aware of. So you have to do those hacks, like inside of FreightShake, we're importing from ~this greatcloak blah 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 instead of just @greatcloak / my library name, like you would in any, like in Slapshot, we just import from @greatcloak / something something. But really, that's the only downside right now. The only other downside, which I noticed since we just deployed this on our beta site and finished up the build process for it, is that every time we build FreightShake now, it's building 10 different libraries, which takes several minutes because it's doing like a separate production build on each one of these. But that's the main downside. So we might just kick it off into a separate libraries project and kind of have them all in there just for that reason, to speed up the build process once this moves into production, and we are relying on those CI build jobs to push out updates quickly.
I understand that there's some troubles there with the speed of production builds. What about the developer experience? Have you had any issues when you're doing your actual development?
So basically, the best developer experience right now with the CLI is to not use libraries and basically keep your code inside your main app project as long as you can. But as soon as you need to reuse it somewhere else, switch over to libraries. The only current downside with the libraries is that it's well, like say you do npm start or ng serve with a CLI project right now, and you have a library inside of there. You change something in the library, you have to go rebuild that library, which isn't that big of a deal. It's like to run that command. You build that library again, the ng server is going to pick up on that, hey, you changed your library files in the dist folder. The only downside is say you have a component in your app and you have a component in some library. The library component is slower to build because it does that whole, I'm not sure if it's a production build, but it's a library build, and it has to do a bunch of fancy stuff to spit out it inside an ng packager in the Angular package format. So I just want to get faster, or have maybe the watch mode more integrated with the libraries, but it hasn't been too big of an issue for me. Yeah.
Yeah, I was just curious. I know that there's support for that has already been discussed and will be coming down the road, from what I can tell. I was just curious about your particular experience. If
I mean, it's not terrible right now, but I came from using a custom Webpack setup where our app got huge and we didn't invest in all the fancy Webpack config. So our builds were taking like half a minute to a minute anyways. And we just went over to the CLI and now it's like 10 seconds. So now we're just like, ooh, that's amazing. But then we just set up libraries and it's like, oh, you have to wait 5 to 10 seconds for a small library to build when you're working on. So we're like, I'm not too picky with it right now, but I just did the accounts thing and some other, kind of like proof of concept, get the whole flow working, get all the configuration. Like when I go take the reporting system, which is a whole bunch of pages and a whole bunch of complicated components, yeah, it'd probably be more of a hassle then, but I'll probably just set up tests and just be running the test instead of rebuilding the library and having to rebuild the whole app. So, you're going to wind up, I'm going to wind up with tests. So it's just encouraging other good behaviors. And I'm sure it's going to get faster in the future.
of course, with all things.
Yeah. Any other questions or comments? Do you guys see maybe uses for this within your companies? My current idea is that, so we have a company and we're making multiple products, so this really applies to us nicely. But the reason we can do that is we have a standardized backend server now that kind of gives us the backend for all these features. So I'm kind of wondering how this could be applied to maybe more open source projects, like Angular Material is a thing, but how could you take and have like an open source reporting system without really binding people to a backend? Or, I'm kind of interested to see what happens with this now that CLI libraries are a thing and you can easily bundle up your routes with it.
Yeah, it's not as clear of a win for my company. We have several different customers, and we usually have at most 2 different projects that we're working on at a time for any particular customer. So we don't usually have things that are as obviously shareable that are user visible. We've definitely there have been times that we've talked about trying to do things like this. So I'm going to share this video with my coworkers to see if what they think about it, but it is not as obvious a win for us.
Yeah. Kind of one of the yeah, Mike.
Go ahead.
Oh, one of my comparisons is if you heard of Basecamp, the company behind that, 37 Signals, I believe the guy's name was DHH, or that's his handle on mine. He invented Ruby on Rails like however a decade or a little bit more than that ago. And that kind of changed the web development on the back end, where it made it really quick to kind of prototype apps and things like that. But what that did was kind of at the language level, it made it really easy to add features. And then you have the whole idea of component libraries, which makes it really easy to have like your buttons and all of your standard, basic components look really nice in that. Or I kind of see this as you can have a whole feature, like you can have a fancy search system built up that you invest a whole bunch of time in for one product. Now you can take that, you can reuse it in like internal admin interfaces or other different products that you're making. So for me personally, I kind of see it as my leg up. If I go to build a product, say like for the Slapshot product now, the core function of that app is to take pictures of pieces of wood and upload it to different systems and manage inventory. But now, because of this system, we're going to be able to have accounts. We'll have permission systems with teams and billing and a very complex, fancy search system just ready to go. We can just install these things in there. You can focus on the main business logic of your app and kind of have all those other things that you need to make a product, just install them off the shelf now.
Yeah, I was going to mention about Lance's model. Lance, just to clarify, you work at a consulting company, correct?
Me or Lance?
Yeah, Rocket, that's correct.
Okay. So yeah, at a consulting company, typically your clients don't really necessarily want to have the code that they're paying you to write shared with other customers that are also paying for their own application. So that model may not work best at except for the fact that if you're working on multiple projects for a single client,
right,
then you could definitely take advantage of utilizing libraries for each individual client,
and
as well as potentially having internal libraries that you can utilize for multiple clients that you just manage internally and own as part of your consulting company.
And another thing that we have done sometimes is when we start to see components and features that might be multiple use, we'll create an open source version of them, and that will be the first initial actual implementation. And then we're not taking intellectual property from one customer to another. We are taking an open source project that we created and giving it to our separate customers. So just have to be clear of that. And so there could be things that we would come up with that could use this approach that way, but it's not it's not like we have the same backend for a billing system for all of our different applications, anything like that.
Yeah, it kind of requires a little bit of a dictatorship, but I think it'll be interesting to see what people do with it. One thing I'm going to visit the Google campus next week, and I get to go say hi to Brad. I've heard that Google has like 100 or a couple hundred internal Angular apps for various things. I was wondering if it might apply to things like that, because this seems to work with like business apps and internal admin interfaces. If you could drop like an advanced search system or reports into all of those internal systems that they have, I thought that would be pretty neat. But it's new. I'm kind of wondering, where can you take this? But yeah, it definitely requires more buy-in, especially if you really want to flesh it out with back-end implementations, which really makes it shine. But if your use case is right, this really it can give you a step ahead of everyone else, I think.
Right. Any other questions, guys?
I didn't have anything else.
Okay.
Yeah, me neither. Thank you, Ed.
Cool. Yeah, I just want to thank you guys for panelists and everyone, but I also want to thank the Angular CLI team. They definitely made front-end libraries much easier for me and kind of gave me that option to go set all that up and dive down this rabbit hole. And also, I know David works on ng Packager. That was a big help when I found those the sub-packages feature. But that really made it all work and come together. But yeah.
Awesome. Yeah, thanks a lot for joining us, Ed. This was great. And thanks to all of our panelists for joining in as well. All right, guys. Have a good evening.
Thanks.